Basically, TypeScript is just a superset of JavaScript. Means that TypeScript has some features that JavaScript don't have. One of those features are types. That's why it is called TypeScript. For us to really understand it, let's take a look at some of the example. So I have just generated some React boilerplate here. This was generated by JavaScript. Okay, so we are just using JavaScript here. It is now running. And also, I have here a TypeScript generated boilerplate, and I use TypeScript here. So as you can see, app.tsx, and the other one, JSX. So wag kayong papalito guys, no? Don't get confused here. So there are two windows kasi here. So I cannot really fit them in one window or one desktop. That's why I separated them. But you can see what we are working on with this logo here and also this one. I just changed the default logo to, you know, TypeScript and also the JavaScript. So for you guys to just know where we are or what desktop we are in. So first is the type. TypeScript has the ability for us to define a variable with a type, with a static type. Okay, so we have different types in JavaScript. Like we have a number, we have a string, we have a boolean, a null, undefined, also a function. So all of those we can explicitly define a variable with a specific type. So for example, in our TypeScript code here, so by the way, wag niyong pansinin yung mga code below. So we're not gonna focus on that. We're just gonna focus on this space, okay? So this is where I'm gonna put all of the code. So for example, let name is equals to John, for example, okay? So this one, this is a valid JavaScript code, right? And if we, let's say, copy it, and then we're gonna put it here, for example. So it is a valid JavaScript code, as you can see. Okay, now the type here, no, this John or this name must be a string, right? So in TypeScript, we can explicitly add string here for us to know that name is a string, and we can verify that by, let's say, console.log type of name. So if we console.log, as you can see here, it is printing a string, right? And if we do the same exact thing on JavaScript, okay, so as you can see, it is already printing string. But why is this important? Why do we need to explicitly add string here? Or why do we need to define a name with a string? Because it kind of makes sense, because name must be a string. It cannot be a number, let's say 7, right? So this is the power of TypeScript. We are getting an error number is not assignable to type string because we explicitly define name as a string. And then we change the value to 7, which is a number. That's why we are getting this error. In TypeScript, we are already getting this error before we even run it. That's the power of TypeScript. Let's go back to JavaScript and let's say we change this to, let's say, 8. So as you can see, there's no error. Okay, there's no error, everything is valid because this is JavaScript. Although name must be a string, since this is just a JavaScript, so it is accepting even a number. Like we can also, you know, change this to, let's say, a boolean like true, false. These are valid JavaScript code. Now, let's go back. Let's change this to this one. Okay, so now that's the importance of TypeScript. Okay, John. And if we, let's say, change the value, so let's say name is equals to 9, for example. So we cannot do that. Why? Because name is a string. But in JavaScript, no, we have, if we type name is equals to 9, it is still valid. Okay, so that's JavaScript. Okay, but I want to mention something here. There are two types of running our code. So there's this compile time and there is a runtime. So in TypeScript, the reason why we are able to do this is because of the TypeScript compiler. So there's a TypeScript compiler here. Like behind the scene, no, because of our build tool, the build tool that I'm using right now is Vite. So runtime, it means it is a time where our code is currently executing. For example, we are fetching data. The system is already running, or the application is already running. Somewhere on that part, our fetching of data was, let's say, declined, or there's something wrong with the server and we got nothing. That is the runtime error. But for the compiled time, before we even run it, like the execution, like the translation of this code into a ones and zeros, no, the machine code, that's the compile time. And for us to really understand this, let's go to the behind the scene, no. So I'm just gonna pull a terminal, and then let's go to dev, yan, and then we're just gonna create a directory, let's say test. So cd test. Okay, what I did there is just created a test directory. So in this test directory, what we can do is to create a demo.ts. So the extension of TypeScript is .ts. Let's add a valid TypeScript code here. So like age, and it is a number, and this is equals to, let's say, 18. And then if we do that, so to verify, yeah. So we have a demo.ts file, and we are gonna run this. No, we cannot run it by this one because this is not a JavaScript one. Unless this is a JavaScript, we can do node demo.js and it will run. But in this case, this is a syntax error. That's why Node is not accepting it, because this is a TypeScript. So what we can do instead is to run this by the TypeScript compiler. So tsc demo.ts. By the way, tsc is just an external command. Like, you can install it, I believe, like this one, npm i-g, and then tsc to install the command. So basically, this tsc is a TypeScript compiler. So tsc demo.ts. So if we run this, so as you can see, no error. So that loading, or after hitting the return or the enter key, that's the compilation time. So what happened on our folder? So if we see this, so there is a demo.js generated, and it's just the exact same thing with this one. And if we view the content of this demo.js, as we can see, it is, it's just translated into a valid JavaScript. So that's what's happening behind the scene. So TypeScript is just a layer, or it's just a wrapper of JavaScript. And after we run TypeScript, it's gonna generate a valid JavaScript code for us. Okay, so that's why we got demo.js. That's the compilation time, guys. So tsc demo.js or ts, after entering return here or enter key here, so that's the compile time. Unlike in runtime, during the execution or during the application is running and then we encountered some error, that's the runtime error. So that's the difference of the two, and that's how TypeScript is doing its job behind the scene. But in our case, in this one, you might ask, why are we catching these errors like this real time if TypeScript catches error on the compile time? It has nothing to do with the compilation time. No, the reason why we are getting a real-time type checking here is because of the IntelliSense, or because of the TypeScript type checking tool that Vite has set up for us. And the compilation time now in this example is after we save this code. So build tool like the Vite, Webpack, it's doing its thing to generate a valid JavaScript code and then finally printing it here or console logging it here. So that's what's happening behind the scene. Okay, so let's go back to this one. So the next thing that I want to talk about is type inference. And you might get confused here, but just keep on watching, no? Let's say let name is equals to, let's say, John, for example. We're not gonna give it a type, but our TypeScript is intelligent enough to determine that name is a string because we put this one. Okay, so this is also the case in Python. So Python has this inferred typing wherein, diba, in Python we can do something like age is equals to 78. So this is now an inferred one. That's also the case, same case with TypeScript and in JavaScript, by the way, but there's a slight difference with the two. I'm gonna show you in a moment. So let's console log the type of this name. No, so if we console log the type, so as we can see, there's a string. Now let's do the same exact thing in JavaScript. So let's delete this, and let's paste it here. So in this code, no, it's just the same thing. It is also inferring this. But how is that? Or what's the difference if both of them are inferring our variable, the name? So the difference here is, let's say for example, in our JavaScript code, let's say we change the value of name to, let's say, 9. So 9 is a number, right? And John is a string. So name was changed into a number type. But JavaScript is allowing that because there's no strict inference in JavaScript. Okay, so there's no strict inference, while in this one, let's say for example in TypeScript, let's say we change this to, let's say, 9. So as you can see, there's already an error. Like, number is not assignable to type string because we inferred this as string initially, and we cannot change that. So that's the beauty of TypeScript. What does infer mean? So like for example, this name here, we declare a variable called name and then equals to a string. So JavaScript is smart enough to tell us that this is already a string. So that's inferencing. So basically you don't need to add a, let's say for example, a string here to make it, this is explicitly defining name and giving it a type. So I hope it kind of makes sense. Next thing that I want to tell you guys is TypeScript has a full support with ECMAScript or ES6. ES6 topics are arrow function, classes, async await, the structuring. So TypeScript has a full support with that. And another thing that I want to talk about is the interface. Okay. So in TypeScript, there is this thing called interface. And this interface is just, think of it this as just an object or a blueprint of what we are gonna define in a moment. So like for example, so interface, we can declare an interface of, let's say, a user. Okay, and then this user has a property of, let's say, a name, and this is a string, and then let's say age of, this is a number. So we have a an interface user. Now, how are we gonna use this? So in TypeScript, we can define a, let's say, a user of, let's say, a user1. So user1 is equals to, or we can add user here. Basically, this is just a type. Like, it has no difference with number, with a string. Okay, we're just explicitly defining this and putting a type on user1. Since we have an interface, we can use that interface to declare a user1. As you can see, there's already a type checking here or an error here that's going on here because we have a missing property of name and age. So it is expecting this name and age. We can now put name here, and another reason for using TypeScript is it is already suggesting us this name because we are using this user as our type. That's why it is suggesting name. So we can do name. And another cool part about TypeScript is, let's say we have a property that is missing in this interface. So it will throw an error, let's say for guitar. So like that one. And if we hover this, so object literal hobby does not exist in type user. So interface and type, those are just kind of similar to each other. So hobby does not exist on type user. So we are not expecting hobby on our user. So yeah, can delete that. And age. Another cool thing about this is, of course, because age is a number and we are expecting a number. So if we add, let's say 7 here. So as you can see, there's already an error, right? The string is not assignable to type number. So we can just move that and let's say 18. Okay. And also, another cool part about this is user1 is declared but value is never read. So we are, getting that kind of warning. Okay. And then console, the log, user1. Okay. So yeah, that's how you do it. Now, let's go to JavaScript. Okay, so since JavaScript doesn't have that interface, so what we can do instead is we can do alternatives, but it won't gonna beat this cool function in TypeScript. Like the alternatives here is we declare a class, let's say a class of, let's say, user, and then we can leverage the constructor, and inside this constructor are the properties, like we have name and age, and then inside this is this dot name, and then this, or mali pala, or this one. Okay, this dot age is equals to age. Okay, but this kind of works, but let's say let, and then we're gonna instantiate this like user1 is equals to new user, and we're gonna put the properties here. So as you can see, we are already having a glimpse of the properties that we can use. Name. So like for example, in our user, we can add, let's say, John, and then the age of 17, for example. So this works, no? Like you can console.log user1. This works, as you can see. Now we are getting a user, and inside that user is age and name. But the problem with this is it doesn't have a type. Like in this age, we can do like, let's say, a string, and still a valid one, right? So what we just leverage here, or what we can just do here, is to add properties but not the type of them. So another alternative that you can use in JavaScript is to install some external dependency like Zod or Yap, but it takes additional resources, additional memory for your project. So that's why TypeScript is a good choice for those kind of stuff. So I think that's all that I can say with TypeScript, and you don't really need to learn it too soon. Be comfortable with JavaScript first, and then if you're comfortable enough, yeah, you can jump to TypeScript. But based on my experience, guys, I just spent like a little time in JavaScript before I jumped in TypeScript, because I don't know, I just like exploring, and I am just the type of person or developer who is, if I encounter a problem, or if I don't know this specific language or any technology, I'm just gonna dive into it, and then if I encounter a problem, that's when I'm gonna read the documentation or watch some YouTube videos. But yeah, try TypeScript. It's gonna save you time on debugging, and it will make you a productive developer.